Scientists have discovered the true ferocity of a huge volcanic eruption off the coast of Tonga in January. Flows of debris stretching at least 80 kilometres across the seabed.
Are we safe? Volcanoes are vents or openings in the ground that spew lava or steam onto the surface of the planet for hours, days, or even weeks. A volcano appears as a mountain or a sizable mound of dirt with a vent or cone on the Earth's surface. The vent has this shape because of the accumulation of ash, dust, lava, and other debris over many years. Earth is home to thousands of volcanoes, most of which are distinct from one another and are brimming to explode. Although there are numerous volcanoes on the Earth's surface, there are also underwater volcanoes. Are these underwater volcanoes prepared to erupt? What would happen in that case? Let's find out. Underwater or submarine volcanoes are fissures where lava can erupt that are primarily submerged under the oceans of the planet. Underwater volcanoes function essentially in the same way as their surface counterparts. Underwater volcanoes are most frequently seen deep within seas and oceans, primarily throughout the Pacific Ocean. Several of them can be discovered in shallow seas as well. It seems that submarine volcanoes are less numerous than terrestrial volcanoes. Though they are the most active on the planet, underwater volcanoes are more numerous than terrestrial ones. Although the total number of underwater volcanoes in the world is unclear, experts estimate there to be thousands of them, dispersed throughout the oceans. The Tamu Massif is now the largest underwater volcano ever recorded. This volcano is situated 1,600 kilometers or 990 miles east of Japan in the northwest Pacific Ocean. Tamu Massif is located about 6,500 feet or 1,980 meters below sea level and spans an area of 553,000 square kilometers, that's 214,000 square miles. The amazing height of this undersea volcano is around 14,620 feet, that's 4,460 meters. According to research, the Tamu Massif is thought to have originated around 145 million years ago between the late Jurassic and early Cretaceous periods. The Tamu Massif's most recent eruption time is still mainly unknown. The underwater volcano may never erupt again, according to experts. The Gardner Pinnacles, one of the largest underwater volcanoes in the world, are another. In contrast to the Tamu Massif, a portion of this volcano may be viewed from the ocean's surface. The volcano is thought to be about 14,000 feet from the ocean's surface and is situated in Hawaii. Its height above sea level is approximately 170 feet or 52 meters. Fonu, which was initially discovered as a volcano in 1820, is primarily found at tremendous depths and has a height equivalent to 5 Eiffel Towers. Due to the size of the volcano, which first formed millions of years ago, its crust has sunk several hundred miles. The volcano's name, Fonu, which translates to turtle rising for breath in Hawaiian, comes from the fact that it is mostly underwater with only a little piece visible. The Fonu's most recent eruption, like that of the Tamu Massif, is unknown. Nonetheless, tests have shown that Fonu's magma was over 3,100 degrees Fahrenheit or 1,700 degrees Celsius when it was still active, making it the hottest recorded magma ever. It should be highlighted that underwater volcanic eruptions do not have the same impact as terrestrial volcanic eruptions, regardless of whether or not these underwater volcanoes ever erupted again. An underwater volcanic eruption may have varying outcomes, depending on how near it is to the water's surface. Prior to a recent undersea eruption off the coast of the island nation of Tonga, few volcanic eruptions in history had been so well chronicled. Researchers are beginning to understand why the Tonga underwater volcano's eruption was so violent and what transpired afterward. Data acquired by 2 teams indicates that when the volcano's center collapsed, a massive volume of lava was released and aggressively reacted with the water, causing a number of huge explosions and hundreds of smaller ones. The greatest air explosion ever recorded on January 15, 2022 when the Hunga Tonga Hunga Hapai volcano erupted. A plume of ash was launched into the upper atmosphere and shockwaves were felt all around the planet. The 300-foot deep and 5-mile wide crater that was left on the ocean's surface by the undersea explosion of the volcano flash-boiled the water. That's true, it's 5 miles wide. With a speed of 250 miles per hour, the tsunami caused by this eruption raced away from the volcano and towards the islands of Tonga. About 50 miles away, people on the islands of Tonga could feel their ears pop due to the pressure change caused by the explosion. Within 10 minutes, a tsunami struck Tonga, inundating the country to a height of 60 feet and wreaking havoc on vacation towns. This explosion had an effect beyond Tonga and the southern Pacific Ocean, as did the tsunami it caused. A global tsunami was caused by the eruption, and it even reached California and the Mediterranean Sea. A pressure pulse from the eruption that went through the atmosphere and caused residents' ears to burst was what triggered this global tsunami, not the explosion itself. The pressure pulse circled the globe numerous times and was observed at meteorological stations all around the world and was incredibly stable. The pulse pulled the ocean surface along with it as it crossed oceans, frequently causing tsunamis all across the world. The tsunami in California, Hawaii, and South America was comparable in size to that of the 2011 Great Tohoku earthquake. It goes without saying that tsunamis can seriously harm coastal areas, yet the issue may become worse due to the rising sea levels brought on by climate change. Shane Cronin, a volcanologist at the University of Auckland in New Zealand, led a team that sailed over a volcano's caldera in May of last year and used sonar to map its structure. Calderas are the central depressions that form when volcanoes erupt. They discovered that the 4-kilometer wide caldera's depth had increased more than 200 meters below sea level to over 850 meters. When the eruption first started, a lot of magma and water interacted, which is probably what caused this big explosion. 20 degrees Fahrenheit water and 1110 degree Fahrenheit magma are coming into direct contact, according to Cronin. Due to the extreme temperature difference, the water erupted when it came into touch with the magma during the eruption. According to Cronin, each collision pushed the water further toward the borders of the lava, increasing the surface area of contact and causing a series of further explosions. The caldera's initial depth was also just shallow enough so that the water pressure did not dampen the explosion, yet deep enough so that the magma was supplied copious amounts of water to fuel the interactions, leading to a number of massive explosions and hundreds of smaller ones every minute. According to eyewitness statements from the eruption day, crackling and noise like artillery fire could be heard up to 90 kilometers away. A severe interaction between magma and water is also suggested by ash grains found in Tonga following the eruption. When the seawater came into contact with the magma, shockwaves strong enough to shatter the grains were created. A different expedition to the volcano was made in April by a group from the National Institute for Water and Atmospheric Research, NIWA, in Auckland, New Zealand. However, they did not cross the caldera. They took samples of ash from the sea floor near the volcano, and the results indicated that the eruption was likely followed by violent pyroclastic flows, which were hot streams of ash and lava that fell over the caldera's submerged walls. The surrounding sea floor was transformed into a white desert by the advancing scorching ash, which completely destroyed everything. Tonga's internet access, which still hasn't been fully restored, was disrupted by these flows, which also propelled tsunamis that swept over nearby islands and rose up to 18 meters in height. These flows spread underwater for thousands of square kilometers after the eruption. Nothing appears to have survived on the ocean floor, while samples are still being examined to determine the extent of the destruction. There aren't even any microorganisms there, in our opinion. That is how hazardous we believe the sediment to be. the NIWA team samples are being used to examine potential effects on ocean acidification and oxygen levels. Yet not everything was destroyed. Following the eruption, satellite data revealed a significant bloom of phytoplankton in the ocean, which ate the nutrients released by the blast. Life was also thriving on neighboring hills that protruded above the ocean floor and were only 15 kilometers away from the eruption. In the history of satellite technology, we have never witnessed anything like this. There may have been clues of what was to come, according to some studies. Cronin concurs that there may have been some advance notice. The day before the eruption, satellite footage depicted a portion of the volcano's projecting northern rim collapsing into the sea. Volcanoes are highly interesting to observe because of the numerous dangers they pose, including sudden explosions, landslides, and long-term climatic disturbances. A stark reminder of the dangers of residing on or close to one of these numerous volcanoes, active or supposedly dormant across the world, are the ruins of Pompeii in Italy. People and animals living in Pompeii were almost instantly covered in ash from Mount Vesuvius over 1700 years ago. More recently, in 1980, Mount St. Helens in Washington state erupted, ripping more than 1,300 feet off the mountain's summit and resulting in an estimated $1.1 billion in economic losses due to deaths, injuries, bridge destruction, and lost crops, amongst other things. Even seemingly dormant or inactive volcanoes can turn out to be dangerous. The Long Valley caldera, which is located in the Mammoth Lakes region of California, started seeping carbon dioxide and helium through the ground in the mid-1990s. Large numbers of trees in the vicinity were killed by the fumes, which may also be to blame for some fatalities and health issues among people. Lahars and pyroclastic flows provide the most risks in connection with volcanic eruptions. Both are incredibly hot combinations of water, gas, dust, and rock that rush down mountainsides, through rivers, and past barriers, burying or igniting almost anything in their path. They frequently travel more swiftly than a person can run, and they have the power to bury vast areas beneath hundreds of feet of debris that reach for miles from the foot of a volcano. Volcanic eruptions can affect the entire world. The August 1883 eruption of Mount Krakatoa also killed some 40,000 people nearby, propelled aerosols and particulate matter far into the atmosphere and around the world, cooling the planet by as much as 0.3 degrees Celsius for a year. Massive lava deposits, sometimes known as flood basalts, have covered entire continents on a much bigger scale. For instance, the Deccan Traps in India span 500,000 square kilometers, almost 200,000 square miles. Geologists have proposed that the lava and accompanying gases may have contributed to the extinction of the dinosaurs in the late Cretaceous period. This massive volcanic eruption, which occurred more than 60 million years ago, has been linked to a long-term planet-wide atmospheric change. The ash plume that the Icelandic volcano released into the atmosphere in April 2010 endangered aircraft traveling across Europe and the North Atlantic. Authorities repeatedly grounded aircraft in the months that followed, leaving passengers stranded and costing airlines and other companies millions of dollars. The air can be filled with millions of tons of particulate matter, which includes microscopic fragments of glass and ash, as well as gases like water vapor, carbon dioxide, and sulfur dioxide. The extent to which these emissions will influence the world's climate is yet uncertain, but they have caused magnificent, vibrant sunsets all across the world. Massive landslides that slide into water or take place below the surface of the ocean might result from volcanic eruptions and create tsunamis. South Africa felt the tsunami that was caused by the Mount Krakatoa's eruption. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.